For example, there might be a rule that the philosophers put down a fork after waiting 10 minutes for the other fork to become available and wait a further 10 minutes before making their next attempt. This scheme eliminates the possibility of deadlock but still suffers from the problem of live lock. If all 5 philosophers appear in the dining room at exactly the same time and each picks up the left fork at the same time, the philosophers will wait 10 minutes until they all put their forks down and then wait a further 10 minutes before they all pick them up again. One of the solution of this classical problem is that a philosopher can only pick up both forks or none by introducing an arbitrator, which is a waiter. In order to pick up the forks, a philosopher must ask permission of the waiter. The waiter gives permission to only one philosopher at a time until the philosopher has picked up both of their forks. Putting down a fork is always allowed. If a philosopher is eating and one of their neighbors is requesting the forks, all other philosophers must wait until this request has been fulfilled even if forks for them are still available. Here, the forks will be numbered 1 to 5 and each philosopher picks up the lower numbered fork first, and then higher numbered fork, among the 2 forks. The order philosopher puts down the forks does not matter. If 4 of the 5 philosophers simultaneously pick up their lower numbered fork, only the highest numbered fork will remain on the table, so the 5th philosopher will not be able to pick up any fork. Only one philosopher will have access to that highest numbered fork, so they will be able to eat using 2 forks.